Okay, welcome to this video for Chem 161, starting on some Chapter 4 materials. And we'll talk about bonding throughout Chapter 4, and today we'll touch on the overall concepts to recognize what bonds are present in a compound and how to go about starting the naming process. Okay, so all this to help us understand bonding in compounds. Okay. So we'll first try to identify when we have to apply ionic bonding naming rules. And to help us recognize when we might do this, we've got to first decide, based on a chemical formula, if we're dealing with an ionic compound or if we're dealing with a covalent compound, which would have covalent. Okay, so, sorry, just touch this up. Covalent bonds. So we asked the question, when might we have one of them? Okay, so we put our attention to the periodic table, and we're reminded of the fact that there's a staircase boundary in here separating the nonmetals from the rest of the periodic table, which are generally called the metals. Okay. To help us also, we have the exception of hydrogen. Hydrogen is a bit of a curious element in that we're going to use the idea that hydrogen is a non-metal when we work with naming. Okay, so hydrogen is a non-metal for naming. Okay. The other thing we need to recall here is that metals tend to lose electrons, so we can expect all the metals to make ions that are positive in charge. Okay, so metals make cations, and nonmetals make anions. That is to say, nonmetals like to accept electrons to make ions, or in certain compounds we will get nonmetals with nonmetals and not have cations or anions, and we'll have covalent materials. We'll see that in a moment. Okay, so if you recall, we know that elements from the first column in the periodic table, group 1, these like to make ions that are positive 1 in charge. So we call that a plus 1 plus charge. Okay. Ions that form that have 2 plus in charge, those come from the second column in the periodic table. The transition metals typically have numerous options for the number of charges we have there, and so we're going to see a later rule in a later video to handle the naming for those. But do recognize that if we have a metal that comes from the transition metals in this inner block, that we are still considering that an ionic compound. Okay. Likewise, if we're still in the metals category but before that staircase boundary, so things like this column, we're going to see that ions tend to form 3 plus in that column, and over in the next column, 4 plus, etc. Okay, so those are the options we have there. Once we cross the staircase boundary, the expected ions that form are anions, as we mentioned, and noble gases will not form ions. Okay, so these remain as 0. They're very hard to form compounds, either covalent or ionic, so we'll assume that they don't react to form ions at all. Okay, and in the 7th column, the halogens, these tend to accept 1 electron. Okay, so that is, they tend to go 1 minus in charge. Those in the 6th column, that is these here below oxygen, these tend to form 2 minus in charge. And those in the next column tend to go 3 minus in charge. Okay, so to predict the charge on cations from metals, avoiding the transition metals, it is simply the charge value is simply the column number. Okay. Metal cations is the column number, the group number. Okay. The charge value for anions is the group number minus 8. Okay, so if we're in the 7th group, minus 8, that gives us minus 1 for the halides. Okay, so that is how we can recognize whether we have ionic compounds or not. So as an example, an ionic compound, these are going to be formed from ions. Okay, so these are compounds formed from ions. Okay, so we have to have a metal and a non-metal if we're going to form ions and therefore an ionic compound. Okay, so a famous example is, of course, sodium chloride. And so we recognize sodium as coming from the first column. So that is sodium 1+. So the sodium ion is how we name this. So the name here is the element name followed by the word ion, sodium ion. And this, of course, is Na1+. Okay, and we recognize this as a metal, of course. The second half of this compound is chloride. Okay, so notice we have used the first part of the neutral element's name, and then we add the ending, the suffix "ide," chloride, and this is the chloride ion. Okay, and so this is the non-metal for this compound. Okay, in the case of magnesium oxide, we have magnesium ion as the metal, and we have oxide, oxygen evolved into the word "ide" with the ending suffix "ide," oxide. We would have a 2- charge on the oxygen, and the magnesium would be 2+, and we would have that compound. Okay, so that is also a metal and a non-metal making an ionic compound there. Okay, covalent bonds exist in covalent compounds. So these compounds or molecules are what form when we have covalent bonds. Okay, so if you hear the term molecular compound or molecule, what we deduce from that is that the bonding that's holding the atoms into that structure are covalent bonds, and we would apply covalent naming rules for that. Okay, so this arises when we have two or more non-metals in the compound. Okay, there will be no metals in the compound. So non-metal is how we recognize covalent compounds or molecules. Okay, an example for this, carbon monoxide. So the first species here, we simply use the element name, carbon, and the next part is monoxide. And we can recognize that the carbon is, of course, a non-metal. And the oxide, is also a non-metal. And so we immediately recognize from the formula and our periodic table that we are handling a molecular compound or a covalent compound called carbon monoxide. We will elaborate here on the rules for when to use prefixes like mono to reflect the stoichiometry, the numbers in the compound here, which are 1 and 1. We'll touch on that in a later video. Okay, so a key takeaway here is that we need to be able to recognize metals from nonmetals using our periodic table to help us identify ionic compounds from covalent compounds to help with naming. All right, thank you.